All right. So yesterday we went ahead and started or continued talking about the unit circle, and we went ahead and looked at how um, given a point on the unit circle or even on the non-unit circle, we ended up with certain ratios that related our central angle to either the x-coordinate, the y-coordinate, or the radius, or both, depending on what you're looking at, right? Cosine, sine, so on and so forth. But what we didn't look at is where these values end up being positive. Okay, so we're going to go ahead and start off with that. So if you recall, this over here is quadrant 1. So I'm just going to go ahead and write quadrant 1. And we see that both the x-axis in quadrant 1 and the y-axis in quadrant 1 are positive, right? Cosine and sine, therefore, are also both positive. Now, if you remember, and I'm just going to talk about the positive angles. Okay, so cosine is positive, cosine of an angle, sine of an angle. Okay, if you recall, tangent, let me write it somewhere else. Tangent of an angle is equal to sine of theta over cosine of theta, right? In fact, we have it down here, right? Sine of theta over cosine of theta. Now, if sine is positive and cosine is positive, then tangent will also be positive. Tangent of theta is also positive. Now, if cosine is positive, then the reciprocal of cosine is also positive. So we have that secant of theta is positive. Same thing with cosecant of theta and cotangent of theta. Okay, but that's not always the case in every single quadrant, as we'll see in quadrant 2. In quadrant 2, if we only think of the positive angles, okay, or the positive ratios, we have that cosine, which is our x-coordinate, is negative in quadrant 2, right? Because it falls on the negative x quadrant. Okay, and sine is positive. So we know for sure sine is positive. Sine of theta is positive. Therefore, its reciprocal is also positive. Cosecant of theta is also positive. Now let's look at tangent. Tangent, like I said earlier, is defined as sine of theta over cosine of theta. If it is that cosine of theta is negative in quadrant 2, then you're going to have a positive number, right? Because sine is positive. A positive over a negative, and a positive divided by a negative is a negative. So tangent is not positive in quadrant 2. Okay? In quadrant 3, we have the following. Okay, we know that both x and y are negative in quadrant 3, so for sure cosine is negative, sine is negative. All right, now let's look at tangent. Tangent's going to end up being a negative over a negative. If we have a negative divided by a negative, we're going to end up with a positive, so that's going to be here. Tangent of theta is positive in quadrant 2, and its reciprocal is also positive, which I will not write down because you guys should know what it is. Okay, and there's another one here. All right, in quadrant 4, same idea. Okay, remember in this case, we have that cosine is positive, but sine is negative. So your positive angles are going to be cosine of theta and its reciprocal, whatever its reciprocal is. Okay? Now, there are certain values on this unit circle where these trig ratios might be undefined or 0. Okay, I'll go ahead and give you an example of one. Okay, let's go ahead and look at this point right here. We know this ordered pair to be 1, 0, right? Now we know that the radian measure associated with this particular point, right, theta, the central angle, is going to be 0 radians or 0 degrees, right? Now, at this point, we have that sine is equal to 0. Okay, so here sine of theta is equal to 0. All right, now if sine of theta is equal to 0, okay, and we have that, let's see, and we have that cotangent of theta is cosine of theta over sine of theta. Okay, if sine of theta is equal to 0, and remember we can't divide by 0, then that means that at this point, okay, cotangent of theta is undefined. Okay, because cotangent, remember, is just defined to be the reciprocal of tangent, which is cosine over sine. If sine is 0, then we have that cotangent undefined. Okay, following that logic, cotangent is also undefined somewhere else because this isn't the only location on the unit circle where sine is 0. Okay, sine is also 0 over here, on this point over here, right? We have that sine of theta is equal to 0. where theta is equal to 180 degrees or pi radians. Okay. Now, if sine of theta is equal to 0 over here, then again, we have that cotangent of theta is undefined. And there is a section on your homework that does ask you to find where it is that certain values are undefined and where they're 0. Okay, just so you know, cosine is going to be the x-coordinate of any point on the circle. And since I can find any x-coordinate on the circle, cosine of theta is always defined. And same thing with sine. Sine is always a point on the circle, and it's always defined. Okay, you only run into issues wherever cosine of theta and sine of theta are equal to 0 in terms of deriving the reciprocal relations as well as the tangent and cotangent ratios. Okay. So let's go ahead and talk about yesterday's example really briefly. Yesterday I gave you an angle, right? And we had to go ahead and associate it with an ordered pair on the unit circle, and then from there derive the ratios associated with each trig function, right? So today we're going to go ahead and do something fairly similar, okay, except that this time we're going to be given the actual ratio itself, and we're going to be looking for theta. Now, when doing this is a non-calculator problem. Anything dealing with the unit circle is going to be a non-calculator problem. Okay, so this is going to be another example. Let's say I have the following. Let's say we're given cosine of theta, and that cosine of theta is equal to 1/2. Okay, now right away I should recall in my little thought bubble, right, that cosine of theta is just going to be the x-coordinate, okay, on my unit circle. So in my head, I should be visualizing, what is it? This, right? Everybody has this on their little green paper, and I hope you're ready for the quiz that will probably take place on Thursday. Now I have that cosine of theta is equal to 1/2. So I need to look for the x-coordinate on the unit circle such that the x-coordinate is 1/2. Okay, and I see that first happens here at this radian value. Okay, whenever theta is equal to pi over 3, we have that the x-coordinate is 1/2, right? Or we can also say 60 degrees. Now, that's not the only place where the x-coordinate is 1/2. If we keep going around the unit circle, just looking at the x-coordinate of every single point that is on the unit circle, we see that theta is also 1/2, or that x, is also 1/2 whenever theta is 5 pi over 3, or 300 degrees. Okay, so we can just go ahead and write or theta equals 5 pi over 3 or 300 degrees. Okay. All right, so that's just really quickly how you can go ahead and find the value of theta when given a particular ratio. All right, let's go ahead and do another one really quick. Call this example A, example B. And let's say this time I want to find secant of theta such that secant of theta is equal to 2. Now, secant of theta, of course, is not directly on the unit circle, all right? But this is a unit circle problem. Okay, what we have to remember here is where exactly secant of theta comes from. Now, we should recall that secant of theta is the same thing as 1 over cosine of theta, right? So I should be thinking, right, let me just continue my thought bubble. I should be thinking 1 over which number will give me 2. If we solve for our little question mark, we should see that we're looking for an x-coordinate of 1/2, because remember, it's going to be 1 over x, cosine is the x-coordinate. Now, in example A, we found out exactly where, which values of theta gave us an x-coordinate of 1/2. So just like in example A, theta here is going to equal to pi over 3, or 60 degrees. And theta also equals to 5 pi over 3, which is equal to 300 degrees. Okay? All right. Now let's look at a non-unit circle type problem. I'll do it on the next page here. Non-unit circle problems, which by the way mean non-calculator problems. Calculator problems. Oops. calculator problems. Okay, so you will be using a calculator for anything not dealing with the unit circle. Let me go ahead and put this away because we no longer need it. Okay, but you will need the calculator. All right, so they're going to be similar to the problems we just did, except this time we're going to have to visualize exactly where it falls on the coordinate grid so we can determine what we need to do. All right, so let's say that in this example, what we're given is an ordered pair. Let's say the ordered pair we're given is 15, -8. Okay, now from this, we know we have a positive x and a negative y, and quadrant 4 has positive x's and negative y. So this is x, this is y. So we're going to be working in the fourth quadrant. Okay, so let's see, that's my positive x. This is my negative y. All right, and I have the point 15, -8. So let's say Trig, 15, -8. All right, so this point right here, the one that's really big, is the point that's on the circle that we're working with. Okay, of course, I'm not going to draw the circle because it would be atrocious to do so from this point. And this, of course, is going to be the origin, the center. So I know that this line segment that I'm about to draw is two things. One, it is the radius of the circle. And if we have a non-unit circle problem, we don't know what the radius is. Not yet, anyway. All right. And I also know that it's going to be the terminal side of the angle that I'm going to be looking for. So I'm going to be ultimately looking for whatever this angle is. Okay? Now, the triangle that I want you to build at all times is going to be the one that's made with the x-axis. Okay, so I'm just going to draw this line straight up and show you that we're working with this triangle right here. Okay? This is my triangle. Now, since I know that this ordered pair, this one right here, corresponds to 15, -8, I know that the x-coordinate, okay, the x-coordinate, in other words, the distance from the origin to whatever this value is, the horizontal distance, right, is going to be 15, right, and it's a positive 15. And this distance right here, and I know it looks kind of crooked, but okay, whatever. Okay, this distance right here is going to be -8. And I know distance is never negative, but for the purpose of setting up these ratios, let's go ahead and use a negative value. Use whatever value they give you. Okay, now the only thing left to find is going to be the radius. All right, so the radius, since we have a right triangle, we can just use the Pythagorean theorem. So we have that the radius is equal to the square root of 15 squared plus, my bad, plus -8 squared, which ultimately gives us 17. So the radius here is 17. This you could have put in your calculator. All right. So, and we're going to go ahead and work with the angle in terms of this triangle, the angle that's created with the x-axis. All right, so this is going to go ahead and be, actually, let's not call this theta, let's call this alpha. Because theta, the angle we're ultimately looking for, is this one over here. Okay, so let's look at alpha. All right, so let's go ahead and start off by writing the trig ratios for the triangle that we have in this particular example. If I want to find cosine of theta, all right, if I look back at my notes, on a non-unit circle type problem, I see that cosine of theta is just my x-coordinate over the radius. Okay, so if cosine of theta is the x-coordinate over the radius, and I have that the x-coordinate is going to be 15, so I'm going to write 15, and that the radius is 17, then cosine of theta is just 15 over 17. Of course, if you don't remember the x over r, just recall this is your angle. Well, actually, I should put alpha. I'm sorry. Alpha. Just recall that cosine of alpha is just going to be adjacent over hypotenuse. So we have 15 over 17. Okay. Continuing, let's go ahead and do sine of alpha. Sine of alpha is just going to be y over r. If you look back at your notes, the y coordinate is -8. The radius, or r value, is going to be 17, so your answer should be -8 over 17. Okay, if we go ahead and have, let me see, tangent of alpha. Tangent of alpha is just going to be y over x. So I just take my y coordinate, which is -8, over the x coordinate, which is 15. Then we're going to go ahead and have secant of alpha. Remember, secant is the reciprocal of cosine. So I'm just going to take what I got for cosine and get the reciprocal. So it should be 17 over 15. Okay. And then cosecant is the reciprocal of sine. So I should have 17 over -8. And lastly, of course, we have cotangent of alpha. And cotangent of alpha is going to be the reciprocal of tangent. So we have 15 over -8. Okay. Those are how we find all of the trig ratios. Now let's say we wanted to go ahead and find theta itself. Remember, theta is starting at the initial angle all the way around to the terminal side. The initial side, sorry, to the terminal side. So this is the terminal side. Okay, however, it's easier to go ahead and find alpha in this case, and we'll go ahead and find theta given alpha. Okay, so let's go ahead and start with alpha. To find alpha, okay, find alpha. To find alpha, you have to use a ratio that's positive. If you use one of the negative ratios, it's going to give you like a funky number. So we're going to go ahead and use a ratio that's positive. And I see right away that cosine of alpha has a positive ratio. So I'll go ahead and use that one. Okay, so we have that cosine of alpha is equal to 15 over 17, right? And we want to solve for alpha. Now this is a calculator problem, so we're going to go ahead and do this on the calculator. In order to find alpha, we need to go ahead and take the inverse of cosine. So we're going to take inverse cosine of alpha equal to inverse cosine of 15 over 17. Remember, what you do to one side, you do to both. So these cancel out, and we end up with alpha equal to, and this value we can go ahead and find on the calculator. Okay, right now, make sure you're working in degrees. So under the calculator page, okay, we're going to go to the trig, right? The trig option menu. Go to cosine, then just type in your ratio, which is 15 over 17. It's 15 over 17. Close your parentheses and make sure to put Control Enter so you get your value. So this angle right here, okay, this angle right here is, what was it again? My bad. 28.0725. So this is going to equal to, right, and assuming that it opens clockwise, right, there should be a negative value. So we have negative 28.0725. Okay, so alpha is going to equal to negative 28.0725. All right. Careful with the direction, right? But remember that that wasn't the value that I wanted. Okay, I wanted theta. I want all of this. Okay, and when we were finding coterminal sides and coterminal angles, okay, we saw what we had to do in order to get back there. And in this case, we're going to have to add 360 degrees to this particular ratio if I wanted the positive angle, right? Because I know from here to here, it's negative 28.0725. If I want to do one full rotation, a positive rotation, I just have to add 360. Okay, so to get theta, I'm going to take alpha, this is in degrees, and I'm going to add 360, one full rotation for this particular case. All right, so I'm going to go ahead and type in negative that angle plus 360. Okay, and we get 331.928. So we have that theta, the angle that we're actually looking for, is 331.928 degrees. Now, if we want it in radians, okay, remember all you have to do is multiply the degrees. Okay, so I'm going to go ahead and multiply that by pi. Pi is down here, if you remember. Pi over 180. All right, make sure to put Control Enter. And you get your radian value of 5.79323. 5.79323, which is in radians. It's understood, by the way, that if it doesn't have a degree sign, it's going to be in radians. Okay, so that's one example. Now, let's say we have another example. Okay, and in this example, we're giving something slightly different. The question itself is going to be very similar, okay, but we're going to approach it a slightly different way. This time, let's say secant of theta is equal to negative 41 over 9. Okay, but we also have to satisfy the condition that tangent of theta is going to be greater than 0. Now, let's go ahead and look at the condition that's given first. Tangent of theta has to be greater than 0. In other words, they're saying that tangent has to be positive, right? And from what we saw at the beginning of the lecture, tangent is only positive in certain areas. Okay, tangent is positive in quadrant 1. Everything is positive in quadrant 1. And tangent is also positive in quadrant 3. So I know that I'm going to be working, okay, in quadrant 1 or quadrant 3. Okay. Now, to determine which one of the two we're working in, let's look at secant. Secant, I know, is the reciprocal of cosine. And cosine is positive in quadrant 1. Okay, so it can't be quadrant 1 because we have a negative secant. Okay, and it is negative in quadrant 3. So everything is going to be working off in quadrant 3. So let me go ahead and draw quadrant 3 so we can visualize what we're working with. There we go. That looks straighter. All right. Now, if we go back to our ratios at the beginning, in case we don't remember, secant of theta, right? Secant of theta is just going to be r over x. So I know that the values that are given to me based on the ratio is the radius of my circle and the x coordinate that I have. Okay, so I know my x coordinate is going to be somewhere over here. And actually, let me go ahead and move this because it's in two different papers. Okay, this right here is my x coordinate. Let's say it's going to be negative 9 because I'm on the negative x-axis. And my radius, the distance from the origin, to the point on the circle such that the x is negative 9 is going to be 41. Okay, now this is the triangle that we're looking at, and this is the angle that we're going to be looking at. In its entirety is going to be this one, right? Similar to what we talked about. Okay, so let's call this angle alpha. And I know the problem says theta, and even on your homework it says theta, but just think about it this way. That does not look like a right triangle, but there we go. Now I'm telling you it's a right triangle. So, since I know the x coordinate, I know this horizontal distance from the origin to the point, so it's going to be a negative 9 here, and I need to go ahead and find my y coordinate. Okay, y, I'll write it over here, y is going to equal to, applying the Pythagorean theorem, okay, 41 squared minus negative 9 squared, and if we type that into our calculator, we just get 40. So I know my y coordinate, this point down here, is going to be negative 40. Because again, we're working in quadrant 3, and in quadrant 3, everything is negative. Okay? No, negative 40. All right, so let's go ahead and find all of the ratios. All right, and actually, we're only going to write a few because I'm pretty sure that y'all understand how to find the ratios. So let's go ahead and start with, let me see, sine of alpha. Right, sine of alpha is just going to be, of course, y over r, which is going to be the y coordinate, negative 40, over the radius, which is going to be 41. Okay? Just like you did in the previous example. And then let's say we want to take tangent of alpha. Tangent of alpha is going to be y over x. Okay? The y coordinate is going to be negative 40. The x coordinate is going to be negative 9. So ultimately, this is 40 over 9. Right? And we can do that for every single trig ratio that is that's asked for. All right. Now to actually find theta, first we need to go ahead and find angle alpha, which is going to be the angle created by the x-axis and the terminal side that we're looking for. Okay, and then we're going to add it to this portion over here. right, to get our full angle in this case. So remember that we're going to take the positive trig ratio, which in this case we'll go ahead and use tangent. So I'm going to take tangent of alpha equal to 40/9. Again, to solve for alpha, we need to go ahead and take the inverse of tangent in this case. So inverse tangent of alpha equal to inverse tangent of 40/9. Okay, we know these cancel out, so we have that alpha is equal to, let's go ahead and check our calculator, trig inverse tangent 40/9, and we get 77.3196 degrees. 3169, my bad. 3169 degrees. Okay, so we know that's the measurement for this angle right here, right? But we still need this full half rotation. Okay, we need a half rotation to add to it. Now we know that the angle measure of a straight line, okay, is going to be 180 degrees, right? Or pi radians. So in order to get the value of theta, we're going to take alpha, the angle that we found, and we're going to add 180 degrees. Okay, so on our calculator, we can just add, take the previous answer, and add 180 degrees, which gives us a total of 257.32 degrees. Okay, so it's 257.32 degrees. Now, if we wanted this in radians, remember that we just multiply by pi over 180. So we can take that answer and multiply by, pi is over here, and divided by 180. Control Enter. And we get 4.49107 radians. 4.49107 radians. All right. So that was just how to find your angle and all of the trig ratios. You can do all the trig ratios based on these two conditions. The value of secant of theta at a particular place, and tangent of theta being a positive value.